Hello students, today we will look at the converse or reverse of Pythagoras' theorem, and this is on page 86 of your textbook. So we have looked at Pythagoras' theorem already. Remember, for any right triangle, the square of its hypotenuse is equal to the sum of its other sides. For example, this is a right triangle. We can know that it is a right triangle when we see that it has got 90 degrees. If it has 90 degrees, it means that it is a right triangle. But then, if we talk about Pythagoras' theorem, we are saying that the square of its hypotenuse, remember, hypotenuse is the longest side, and for this triangle, the longest side is side AB. So, the square of hypotenuse, it means that if we get AB squared is equal to the sum of its other sides. Other sides we have CB and AC. So AB squared is equal to BC squared plus AC squared. Once we do that, this is what we call the Pythagoras' theorem. Or you can say that since hypotenuse is C, so we have C squared is equal to BC, which is A, so we say A squared, plus AC, which is B squared. That is what we call the Pythagoras' theorem. Pythagoras' theorem is the same as Pythagorean theorem. Now, this is actually what we are talking about. Look at that triangle. We can see that it is a right triangle because it has got 90 degrees. The hypotenuse is 10 centimeters. So, once we get 10 squared, we will get 100. Then we get the sum of other sides, 6 and 8. So we get 6 squared plus 8 squared. This is equal to 36 plus 64. You see that again we get 100. So you see that once you have the hypotenuse squared, it is the same as when you have the square of other sides, 6 squared plus 8 squared. So that is the Pythagoras' theorem. We already know about this. So student, today let us look at the converse or reverse of Pythagoras' theorem. The reverse of Pythagoras' theorem is the same as the opposite of Pythagoras' theorem. For any triangle, if the square of one side is equal to the sum of the square of other two sides, then that triangle is a right triangle. Look at this triangle. We don't know if it is a right triangle or if it is not. But if the hypotenuse, that is AB, if we square it, and then we find that it is equal to when we square CB plus AC, then we say that that is a right triangle. We say that this is a right triangle. But if we find that AB squared is not equal to CB squared plus AC squared, then we say that this is not a right triangle. It is not a right triangle because AB squared is not equal to CB squared plus AC squared. So it means that if AB squared is equal to CB squared plus AC squared, then this triangle is a right triangle. For example, look at this triangle. The hypotenuse is 10. If we get 10 squared, we will get 100. And then, if we get 6 squared plus 8 squared, we will get 36 plus 64. And still, it will give us 100. Now, you see that 10 squared is equal to 6 squared plus 8 squared. Then it means that this is a right triangle. It is a right triangle. In other words, the biggest angle is 90 degrees. I hope this is clearly understood. This is what we call the reverse of Pythagoras' theorem. Let us look at an example. Determine the following triangles, whether they are right triangles or not, according to the given sides. Number 1, ABC, where AB is 39 centimeters, BC is 15 centimeters, and AC is 36 centimeters. Number 2, PQR, where PQ is 28 centimeters, QR equals 20 centimeters, and PR equals 19 centimeters. So we want to check if triangle A is a right triangle or if it is not right triangle. Number 2, we check if PQR is a right triangle or if it is not a right triangle. Now, let's begin with number 1, ABC. Now we have AB is 39 centimeters. BC is 15 centimeters. AC is 36 centimeters. So we need to know which one is hypotenuse. Remember, hypotenuse is the longest side. So it means that AB, which is 39 centimeters, is the hypotenuse. So, since AB is the longest side of triangle ABC, so we can say 39 squared. What does it give us? 39 squared gives us 1521. Okay? This is AB squared. Now, let us check. What about What about BC squared plus AC squared? BC squared is 15 squared and AC squared is 36 squared. So 15 squared gives us 225 and 36 squared gives us 1296, and all together we get 1521. Now student, tell me, is this a right triangle or not a right triangle? Because you see that AB squared is 1521. Then BC squared plus AC squared is also 1521. If AB squared is equal to BC squared plus AC squared, then it means that it is a right triangle, because AB squared is 1521. Also, BC squared plus AC squared is 1521. So it means that this is a right triangle. Right triangle. Okay? So ABC is a right triangle and C is the right angle. Okay? In example 2, we have triangle PQR, where PQ is 28 centimeters, QR is 20 centimeters, and PR is 19 centimeters. So, according to this, you see that PQ is the longest side because 28 is bigger than 20 and 19. So, it means that PQ is the hypotenuse. PQ is the longest side. So now let's check. If we have PQ squared, then it will be 28 squared. Okay? And 28 squared gives us 784. You check that? Now, let us see what is QR squared plus PR squared. This will give us QR, which is 20 squared, plus PR, which is 19 squared. And of course we know that 20 squared is 400 and 19 squared is 361. Their sum is 761. Now let us check. We have got 784 as PQ squared, but we have 761 as QR squared plus PR squared. Is this a right triangle or not a right triangle? What do you think? You can see that PQ squared is not equal to QR squared plus PR squared. So it means that this is not a right triangle. this is not a right triangle. So PQR is not a right triangle. I hope that you have really understood what is called the reverse of Pythagoras' theorem, or it is the same as the converse of the Pythagoras' theorem. And remember, Pythagoras' theorem is the same as Pythagorean theorem. Thank you so much for watching this lesson. For more examples and practice questions about this lesson, get this textbook on page 86 to 90. In the next lesson, we will begin a new unit, and this unit is called Statistics. Thanks for watching and have a good day. Goodbye.